Hey all, the purpose of this video is to show you how to make one of those Desmos simulators that I showed you in class the other day, so when you get ready to do your project, you'll be able to form one on your own. So what I've got here is the answer key to the problem that you worked on in class, the puncher problem, and we're going to work with these equations up here to build this Desmos simulator. So I'm going to do this in 3 videos. Most of them, all of them are very short, all of them are very short. So the first thing I'm going to do is to build the path that this projectile follows. So to do that, on Desmos, I'm going to place as a single point the X position, the horizontal position, and the Y position. So as a single point in parentheses, I'm going to type in the X position first. I've got 46.6885, and there's some other numbers there, and I could have included more of them if I wanted to. For now, I'll just use that times time. And since this is a point, that's the X coordinate. The Y coordinate is going to be this Y position equation here. So negative 16t squared plus 58.6956 t plus 1.3. Okay, so we've got everything typed in. So I'm going to move the Desmos stuff into the feature here so you can see it. This is probably what yours would look like when you first get in there. So we have to make a couple of adjustments before we can actually get started with this. First of all, this problem doesn't take place in just a 0 to 6 or 0 to 7 window. We need to make sure that the window we have actually contains the entire problem. So what I'm going to do is bring this over in here so you can see the whole screen. This little wrench right here is what you use on Desmos to adjust the window. So I'm going to hit this wrench, and I'm going to adjust my X and Y axes so that they match the problem. So my X should start at 0. And the range, the distance that the receiver was standing from the puncher was what? 169.10 feet. So let's make that 170 feet. Because we want it to be actually contained entirely in the picture. And we also need to adjust our y-axis. Well, we don't need to go below ground, so we can start that at 0. And we want to be able to see the whole trajectory, so we need to know what the maximum height was, which we found in the problem. It was 55.13, so I'm going to make that my maximum here, a little bit bigger than that, so let's say 60. All right, so my scale is now set up and appropriate. But if you look at this, this is only showing you part of the projectile, like the path. The reason for that is if you look right over here underneath what I typed in, this is the time interval over which it's graphing. And it's only going from 0 second to 1 second. That's sort of what Desmos defaults to. We need to actually have it go from 0 when it starts to the hang time where it actually gets caught. And that hang time in this problem, if you remember, was 3.621-ish seconds. So here, I'm going to click that and hit 3.621. And now, if I remove myself from the picture, oop, I made myself huge. You should be able to see that it actually shows the entire path of the project. There we go. Let's move myself out of the way. The next video will show you how to get that moving ball along the arc.